Welcome everyone to this lecture series on thermodynamics. In this lecture series, we will explore principles of thermodynamics, its laws, and its application in various fields, including engineering and physics mostly. We will begin by introducing the basic concepts of energy, work, and heat, and how they relate to each other. We will delve into the laws of thermodynamics, including the first and second laws, and the implications for heat transfer and conversion. We'll also cover topics such as thermodynamic cycles, phase transitions, and thermodynamic potentials. We will discuss how these concepts apply to real-world scenarios such as refrigeration and air conditioning, combustion engines, and renewable energy systems. By the end of this lecture series, you will have a solid understanding of the principles of thermodynamics and its applications. You'll be equipped with the tools to analyze and design thermodynamic systems and to apply these concepts to the real world. So sit back, relax, and let's dive into the fascinating world of thermodynamics. In this video, we're going to cover three different subjects. We're going to go over an introduction of what thermodynamics is and go over the system definition that we'll need to move forward in this lecture series. So the first question that we have to ask ourselves is, what is thermodynamics? There are many different definitions of thermodynamics, but the most general definition is that it's a study of energy. And more specifically, it's a study of energy and its transformations and how the energy transforms from one state to another and how we look at energy. And we're going to relate this energy to the properties of matter. And what we mean by that is that whenever we look at a system and its properties at a certain temperature and a certain pressure and a certain volume, we're going to study the energy related to that and how the energy transfers between things. Another definition of thermodynamics that we can use is the science of energy and entropy. We've already talked about energy, but entropy can be defined as the measure of disorder or randomness of a system. And we'll go a lot more into detail as to what entropy actually means scientifically. Now, thermodynamics can be rooted into the Greek words heat and power. So thermo stands for heat and dynamics stands for power. So we're going to be looking at a study of heat and power throughout this lecture series. We're also going to define the following terms: system, energy, properties, entropy, heat, and power. And we're going to start with discussing what the system is and what the system means in a thermodynamic analysis. So whenever we study a thermodynamic system, we have to think of a certain system that we're studying. We can choose for our system to be very, very large or very, very small. So we can, for example, choose a system that would be microscopic, or we can choose a system that would be a whole room or a whole building, or even the whole atmosphere of the Earth. So we can do different types of thermodynamic studies based on the size of our system. The system itself can be defined as a 3D region of space bounded by an arbitrary space. That space is also sometimes called the boundary. Now, there are two main types of systems that we're going to be studying throughout, although we'll see there are more subtypes. And these two types of systems are called closed systems and open systems. So to start off with a definition, a closed system is a type of thermodynamic system that it can exchange energy with its surroundings but cannot exchange matter, or in other words, mass. And for example, a sealed bottle of soda would be an example of a closed system. Now, the most common example that we use in thermodynamics to define this system is a piston cylinder assembly. So you can see that in the drawing here we have a piston, a cylinder, and we can define our system to be whatever we want. So we're going to define our system by the red boundary being drawn right now. So the inside of this boundary would have our system, and the outside would be called our surroundings. So inside this boundary, we have a certain fluid shown in red. And as engineers, we can really decide what the system is. So we could actually define the system as more than just what is bound by the red dotted line. But in this case, we decide to choose this. And if you think about it, this is an example of a closed system because the mass is fixed inside the piston cylinder. You can't take mass in or out of the system. And this is called a controlled mass system as well. So we're just going to highlight now the system in yellow, the boundaries in red, and the surroundings in green, so that you have an idea of where to go. So the next type of system that we're going to study as we finish off this drawing is an open system. And an open system is a type of thermodynamic system that can exchange both matter and energy with its surroundings. So for example, a pot of boiling water on a stove is an example of an open system because it allows for mass to escape. We don't have a piston closing it off at the top. Now, another very good example of this is, which is used a lot, is fluid flowing through a pipe. Okay, so when we have fluid flowing through a pipe, we have a fluid coming into a pipe, a fluid coming out of a pipe, and we can decide to analyze any part of this control volume, which we call a control volume. So anywhere within the pipe, we can fix a region, and that region would be called our system. So right now I'm showing you in red that we are defining a system with some fluid going in and some fluid going out of the system. And if you look at this over time, through the boundary, you'll notice that if you just fix the boundary and look at the boundary, you're constantly going to have mass flowing in and out of our boundary. And this can be in addition to heat also coming in and out of our system, because we could have heat coming through the walls or through the boundary of the control volume. So that's very interesting in terms of the two different types of systems that we're going to be studying. We're going to start by studying mostly closed systems, but then we will go into studying open systems and looking at both together. To finish off and to summarize, what we can say is that the control mass system is usually a closed system and mass does not change throughout time. So if we analyze the system over time, we will know that the mass will not change within the system. Now, a control volume system, on the other hand, the mass can change over time and will be replaced. So matter will cross the boundary and will allow for the mass to change over time. So that's the main difference between those two systems. And we're going to be analyzing these two systems in quite a lot of depth as we move along. Thank you for watching. If you found this video helpful, please give it a thumbs up and subscribe to my channel for more content like this. Don't forget to hit the notification bell to stay updated on my latest videos. Your support helps me to continue creating informative and engaging content. So if you want to learn more about this topic or have any suggestions for future videos, please leave a comment down below. Thanks again for watching, and we'll see you in the next one in the video series.